Alright, so now we're on the last page of the review. Let's see, we need to find the inverse of each solution, or each function algebraically. Find the inverse of each function, find the inverse. So a lot of inverse stuff here, and then finally, variation problem. So the very top, we just follow the same pattern that we do every time for finding the inverse, and that is step 1, change the f of x into a y. Number 2, change all the y's to x's and change all the x's to y's. And then step 3, solve for x. Solve for y, my bad. Alright, so we need to get y all by itself. Y equals is what we're looking for there. So, let's go ahead and work on this one. So following that pattern, we change the f of x into a y, so y is equal to x over 12. And then we change the y to an x, and whatever x's we have to y's. And then the last step, get y by itself. So to get y by itself, if it's y divided by 12, we multiply both sides by 12, and we get 12x is equal to y. That's our inverse function. And we write it up more formally like this. F inverse of x, so f negative 1 of x, is equal to 12x. There's our inverse function. Okay, next one. So we change the f of x to a y. We change the y to an x, and whatever x's we have to y's, so 4y to the third minus 3, and then we get y by itself. So in solving, we get rid of the minus 3 first, so we add 3 to both sides. X plus 3 is equal to 4y to the third. Divide both sides by 4, we get rid of multiplication next, so x plus 3 over 4 is equal to y to the third. And then if y to the third is equal to x plus 3 over 4, we get rid of that third power by taking the cube root of both sides. So then we get y is equal to the cube root of x plus 3 over 4. There's our inverse function, and more formally I can write it as f inverse of x is equal to the cube root of x plus 3 over 4. And that's how I write it out. Alright, that's the second inverse. Now for the third one, same pattern. So change the f of x to a y, change the y to an x, change the x's to y's, and solve for y. Alright, so we first square both sides. X squared is equal to y plus 10, and then subtract 10 from both sides, and we get x squared minus 10 is equal to y. Okay, so there's our inverse function. F inverse of x is equal to x squared minus 10. Alright, now you might be thinking, okay, well wait a minute, I have this quadratic over here, and then a square root function over here. They don't look the same. You know, it doesn't look like I'm reflecting over the line y equals x if I graph this out of my calculator. In fact, I'll show you real quick how that looks. Alright, so if we graph the two of them out, just to kind of make sense of all this stuff, we do square root of x minus 10, plus 10, my bad. And then graph the other one, x squared minus 10, x squared minus 10. So there's our square root. There's our quadratic. Notice that if we graph out y equals x, it won't be reflected over that line. So here's the deal, here's why. It's actually because of the fact that this has a domain restriction. Its domain is, you know, if we solve for it, x plus 10 needs to be greater than, well, let's just go ahead and solve it, whatever. X plus 10 needs to be greater than or equal to 0. If we get x by itself, subtract 10 from both sides, x has to be greater than or equal to negative 10. That's the domain. And then its range, if you look at the square root function, starts at 0 and goes up to infinity. So the range is going to be y is greater than or equal to 0. Well, remember that we changed the range in the domain here. So technically this quadratic is actually only going to be this right-hand side of the graph. So that's why it would reflect over that graph, just because of this domain restriction early on. Okay, anyways. Now find the inverse of each function, then verify it. All this means is that we're going to compose the functions into each other, and it should get x as a result if it is in fact the inverse function of the original function. So here's the function. Let's get the inverse. So more practice of this stuff. Y is equal to 6x minus 1. X is equal to 6y minus 1. Solve for y. Add 1 to both sides. X plus 1 is equal to 6y. Divide by 6. Y is equal to x plus 1 over 6. and then more formally f inverse of x is equal to x plus 1 over 6. So there's our inverse function. All right, now let's go ahead and prove that if we do the composition of them, then we'll get x. So I'm going to do f of x first, f of f inverse of x, and I should get x. Let's see if that's the case. So if I take the f function, 6 times the input, blank, minus 1, and then for the input I'm using the entire inverse function, so I plug it in, x plus 1 over 6. So the 6 times, so the 6 in the numerator, 6 in the denominator cancel out, and I'm just left with x plus 1 minus 1, and then the 1's cancel out, and I just get x. So that one works out. Now let's do the other one, so f inverse of f of x. And let's see if that is equal to x. So we take the f inverse function as our template, so it's going to be the input plus 1 over 6. All right, so my input is going to be the entire f function, which is 6x minus 1. So the minus 1 and the plus 1 cancel out, so we just have 6x over 6, which sure enough turns it into just x. So yes, this is definitely the inverse, just checking it out to make sure that it works. Now let's try this one out and see why we actually aren't going to be able to find the true inverse here. So find the inverse of each function. This is a quadratic, so if you quickly graph that out, I'll just graph it out on my graphing calculator real quick just to show you what I'm talking about. Okay, so x squared minus 7, x squared minus 7, graph. So if I graph it out, I have this quadratic, and it fails the horizontal line test. So it's not one-to-one. That means that we're not going to be able to find a function over the entirety of its domain. So we're going to end up with some weird solutions here. And that's why this verify part's not going to really work out too well. We'll see that in a second. So we change it to y is equal to x squared minus 7. Then change the x's to y's to x's. Then solve for y, so add 7 to both sides. X plus 7 is equal to y squared. Take the square root of both sides, and you actually get two functions, plus or minus square root of x plus 7 is equal to y. And this creates two equations, so you'd have to do a domain split for it. So for this one, this is an example of one that we would not ask on the test, just because it creates a conflicting kind of answer, because you'd have to restrict the domain here probably to just x has to be greater than or equal to 0, in which case the y values would be greater than or equal to -7. So that means that you'd have to pick one of these positive or negative functions over here as your inverse function. So for this one, this would be a little bit much. So you can expect something more along the lines of like this one or something like it. That level of difficulty rather than this one. Okay, number 18. Find the inverse of each function. On your calculator, graph them. Okay, so that's pretty easy. We just do the same steps that we did before. Y is equal to 1/2 x minus 3. X is equal to 1/2 y minus 3. Solve for y. Add 3 to both sides, and you get x plus 3 is equal to 1/2 y. Double both sides, and you get 2 times parentheses x plus 3 is equal to y. Then you can distribute the 2 if you want. 2x plus 6. And then I'll write that out as my inverse function. Okay, so now I'm going to graph the two functions, the original function and the inverse, and verify that they are inverses. If they are indeed inverses, they're going to be reflecting over the line y equals x. So I'm going to graph this, and also y equals x on my graphing calculator and see if that's the case, that they reflect over that. So 1/2 x, so 0.5x minus 3. One function, and then the other one is going to be 2x plus 6. And then the last one is y equals x. Graphing it out. There's the first one. There's the second one right there. And then the line y equals x. Sure enough, it reflects over that line. So yes, this is indeed the inverse function. Okay, so same thing over here. We've got to graph these out. This is going to be very similar to this problem over here, where we have this domain restriction that's going to allow us to have the inverse function graphed out and reflected over the line. So for this original function, the domain is going to be, let's see here, x plus 1 has to be greater than or equal to 0, so x is greater than or equal to -1, so that's our domain. And then the range is going to be from y is greater than or equal to 0. If you graph it out, you'll see it pretty obviously. So our inverse function is going to be the opposite of that. The y value and the x values are going to be greater than or equal to 0, and the y values are going to be greater than or equal to -1. So let's get the inverse real quick. So y is equal to the square root of x plus 1. And then x is equal to the square root of y plus 1. Square both sides. X squared is equal to y plus 1. Subtract 1. X squared minus 1 is equal to your inverse function. Okay, so now I'm going to graph out the inverse and the original function and y equals x and see how that looks. And, when I graph this second one out, I'm going to show you another trick where you can graph it so that it's just a part of the graph as well. No, never mind. We'll look at that a little bit later. Let's just graph it out and then we'll explain all that stuff, kind of explain it away. Okay, so y equals, and then we graph out the original function, which is the square root of x plus 1, so x plus 1. And then we've also got x squared minus 1, so x squared minus 1, and then x, and then let's graph it out. So there's the square root function, here's the quadratic, and then there's the line y equals x. Okay, so with this domain restriction, x is only greater than or equal to 0. It'd be the right-hand side of the graph. So imagine that like the left side of the parabola is gone, and it's just that part. So that does indeed reflect over there when you graph it out. Okay, now for the last two, determine if the two functions are inverses. If they are, then this is true. If I compose them, then I should get x. Let's verify that that's the case. So I'm going to first try f of g of x. And if it is the inverse, that means that I should get x. Let's see if that's the case. So f of x is 2 times the input minus 1. Now I'm going to plug in g of x, 2x plus 1, and distribute the 2 in there. I get 4x plus 2 minus 1. And then combining like terms, I get 2 minus 1 gives me a positive 1. So this is not x, so therefore this is not the inverse function. So let's write that out instead of putting a big x there just so it's not confusing. Not inverses. And that's because it does not equal x at the very end. Let's see if this one gets the job done. So let's try f of x, or f of g of x first. All right, so let's see. F function is the square root of the input plus 1. So as the input, I'm going to plug in x squared minus 1. All right, so x squared minus 1 plus 1. Well, minus 1 and the plus 1 cancel out, and I get square root of x squared. And, that means that I can plug in any x value here, and then it'll end up canceling out. It would be positive, so we can take the square root of a positive number, and that's okay. So this just ends up being x. So we're good to go for that one. Now let's try the other way around, g of f of x. All right, so the g function is something squared minus 1, and then that something is going to be the square root of x plus 1. Well, here's a problem that we have. It's a domain restriction right here. X has to be greater than or equal to negative 1 for this to work out. Otherwise, we'll get negative numbers if we go below negative 1, like negative 2, negative 3, negative 4. And if that's the case, then we can't use this function at all. So this is another case where we have a problem, an expression that, two expressions that like kind of make a contradiction, where we'd have to have a little bit more information, like this one where we had to put together the domain restriction. This one would probably need a domain restriction from the get-go on here. And if it did have that domain restriction, then if we squared this square root, we'd get x plus 1 minus 1, and then we get x for our answer. But since it's implied that this has a domain restriction and this does not, then technically this entire function is not the inverse of this one. So we would need that in there to kind of verify that. Anyways, number 20. So again, another problem where if it was on the test, it'd have more information. But in general, just kind of go through the same process, and if it equals x, then you've got your inverse. So the last ones we have are these variation problems. So use the given information to solve the variation problems. Y varies directly with the square root of x. Okay, so if it varies directly with it, then that means that it's going to follow the same formula. Y is equal to k times, and then square root of x, so square root of x. So that's how that one goes. Now let's go ahead and plug in the y value and the x value to solve for k, because that's what we always need to do, find the k value, and then either just get an equation or plug in some numbers to find like a specific value, like what we're going to be doing on part B. All right, so if we plug in 40 on for y, we get 40 is equal to k times the square root of x, which is 4. Square root of 4 is 2, so this gives us 40 is equal to 2 times k. Divide both sides by 2, and you get k is equal to 20. All right, so then we just plug that back into our original variation problem. So k is equal to 20. 20 right there, and that's the direct variation problem that they're asking for, the equation. All right, so that's 20a. Now let's do 20b. Y varies inversely with the square of x, so y is equal to, and then the square of x means x squared, so x squared goes in the bottom, because inversely means it's going in the denominator, so k over x squared. If our y value is -4, I plug those in, so I get -4 is equal to k over x is 2, so 2 squared. And then after a little bit, I need to find the equation and then plug in -3 for x and see what I get. So let's see what we get here first of all for k. -4 is going to be equal to k over 4. Multiplying both sides by 4, I get k is equal to -16. So -16 is our k value over here. And now I'm going to plug in -3 to solve for the y value. So if I plug in -3 for x, I get y is equal to -16 over -3 squared. -3 squared is -3 times -3, which gives me a +9, so I get -16 over 9, and that's my answer for y. And that completes the group work assignment. So yeah, if you need some additional help, don't forget to, seek out some help. Going for some help in the morning maybe, or email your teacher, or consult some videos, talk to a tutor, talk to a sibling that's taken the class or has taken the class, or go to your parents, any of that stuff. Just get some help if you need it. All right, that's it.